Hello everyone. This lab we're going to discussing the delta to Y three-phase transformer bank. Delta to Y three-phase transformer bank is the most common three-phase distribution transformer bank. And also you have some special requirement for this delta Y three-phase transformer bank. If you remember the phasor diagram for delta to Y, the arrow for the phasor actually pointing out instead of all pointing in for other Y connect the transformer bank. So we look at the connection first. We have a 240 volt supply down here. The supply is 240 volt three-phase. The same as each transformer is rated 240 480 and the 120 240 dual winding transformer. Each transformer is 1.5 kVA. The transformer ratio is 2 to 1. And the primary side, the lab asks us to connect in parallel delta. So I parallel H1, H3 together, H2, H4 together to make the parallel winding connection. A-phase transformer, H1 connect to line A, H4 connect on line B. B-phase transformer, H1 connect on line B, H4 connect on line C. C-phase, H1 connect on line C, H4 connect back to line A. The secondary is the most important one because the CSA requirement is the phase displacement is 30 degrees. So the connection for the secondary is very important to know because if you remember the phasor diagram or if you remember the summary I gave to you, the H4 have to follow wherever X4 and the H4 we connect onto the same line. So for here, H4 connect on line B, X4 we connect onto the line B also. All the transformer, the X1 gonna connect onto the neutral and I ground the neutral down here. So for A phase, the X4 actually connect on line B, B phase, X4 connect on line C, and the C phase, the X4 connect on line A. So that's the special for this delta Y transformer. It's the most common distribution for three-phase power transformer. The load, it's also 15 ohm each phase. So I have 30 ohm resistor. I connect them in parallel. It's a Y connected load. So here the transformer bench connection. And next we're going to do the calculation. Primary side, the line voltage is 240 volt. It's delta connected, so the phase voltage also 240 volt. The secondary side, the phase voltage, because the transformer have a ratio 2 to 1, so the phase voltage on secondary side, we have 240 divided by 2, give me 120 volt. Secondary side, it's a Y connection, so the line voltage is going to be √3 higher than the phase voltage, give me 208 volts. The load is connected in Y, so the line voltage for the load is came from the secondary of the transformer bank. So line voltage is 208. The phase voltage for Y connected load, the phase voltage will be √3 less. So 208 divided by √3 give me 120 volts. Once I find out the load voltage, I can calculate the load current. Phase current for the load, phase voltage divided by resistance, give me 8 amps, because the load is connected in Y, so the phase current is equal to the line current for the load. Now I can calculate the total kVA for the load, 3 times E phase times I phase, give me 2880 VAs. So that's how much VA the load gonna draw. Now I can calculate secondary transformer, the phase current. I'm just going to use the total load kVA to do the calculation. Total load kVA divided by 3 divided by phase voltage. Gave me 8 amps. The secondary is a Y connection. So this 8 amp also the secondary line voltage for the transformer bank. You can see this 8 amps is the same for secondary of the transformer. And also it's the same for the load because both the secondary transformer and the load are Y connected. Now the primary, I calculate primary phase current first, kVA divided by 3 divided by E phase, give me 4 amps. But because the primary is connecting in delta, so the line current gonna be √3 higher than the phase current. So root 3 times 4 amp, give me 6.93 amps. That's my line current on the primary side. When we have a Y connect the secondary, when we do the connection, we have to make sure, we have to check the secondary has 3 balanced line voltage. So that's going to make sure we have all the transformer connected right. Also, because we have a Y connection, so we have to ground the neutral point on the secondary. So here's the calculation. Next, let's go to the lab bench to see how we did the lab.